I'm going to create a course on Agentic AI, but before we get into there, I want to explain the theory behind it and the fundamental concepts of agents because this is very important. Let's make an example. You can buy a car, but do you really know how it works from the inside? How all the components move inside the motor? Do you truly have that knowledge? That's my goal with this course. My goal is that you can truly deeply understand the theory of agents, and then when you work with the open frameworks like CrewAI, AutoGen, and others, you can create better models and better agents because you will understand deeply the theory and the fundamental concepts of this technology. Something remarkable to mention is that us as humanity has always been intrigued by the fact of writing automated machines that can execute, can move, can be as us. And this is one example of it in the Iliad, in the book 18. Vulcan writes about the tripods, and these were machines that moved themselves. They were autonomous and they were there to serve the gods. So I think us as species has always been very interested in creating this type of machines, and in the past years we have made so much advance on AI that is remarkable, and one of those technologies is agentic or agents, and this is the topic of this course that I will be creating on. Before we start, we have to define some concepts. So the first one is, what is artificial intelligence? So we can say that artificial intelligence is an integrated computational science. And this integrated computational science is coherent. It has a formal theory around it and is very based on experimental designs and observations that improve, again, the formal theory and makes it more coherent. Something to recall about artificial intelligence is the fact that the main goal of it is to synthesize analysis of computational agents and how they interact intelligently. We need to understand that agents are all around us, and all these agents act in a way that makes them intelligently. We will see what that means, but just to call agents can be anything from a human being, it can be a robot, it can be a dog, it can be a car. They are agents. Now in artificial intelligence, we have agentic AI that acts as specific, specialized problem solutions on application domains. Maybe you want an agent that behaves as a marketer or as a financier analyst. You can create this now with CrewAI, for example. And then I will close up with the central engineering goal of artificial intelligence. What is the end goal the engineering is at the end looking for? Something to recall, like I mentioned, is that all these agents act on an environment. So we can say that an agent is a robot. We can say that a dog is an agent, and us as humans are agents. And each of us do different things on this environment. So when we face a situation on the environment, any of these agents that I mentioned, they take actions, they make decisions, they act upon this information from the environment. So the fundamental idea here is that this specialization of artificial intelligence, that is agents, tries to study how this agent make these decisions and trying to understand and figure it out how it takes all of this environmental information and acts upon for the betterment of the agent. And then we need to understand what is like the conditions to call that agent is an intelligent one. How would you find that a agent acts intelligently? Well, there are some short-term goals, long-term goals, and the consequences of its actions. This is something that you can measure on an agent to understand if it is acting intelligently or not. Of course, it has to be very flexible to the changing environment and the changing goals, because this is where it's taking the information to act upon. And also, it has to learn through experience. It has to be conscious enough to understand through its errors and improve every time to be better decisions. And something very important to mention is that the agents by itself has some limitations that they have to be worked upon. They work on a very specialized area. They have finite memory, finite resources, and finite amount of time to execute tasks. If we understand this, then we need to get into what is called computational agent. So what is this? Basically, all this environment, we agree on that. We have some agents. These agents can be humans, can be robots, can be a dog. This then makes decisions. And those decisions are called primitive operations that can be implemented in a physical device. And this device that are taking these decisions can be a human brain or a computer machine. And then based on these primitive operations, then it can take actions. That is what is called computational terms, or what is called an agent explained in computational terms. And like I mentioned before, the agents have some limitations that they have to face. That's a fact. And that they have to try to overcome. Let's say you tell an agent to solve a specific problem and it has some resources. It has to try to do the best action possible independently of what the resources it has. Just to close up on this small class, I just want to mention the goal of engineering on artificial intelligence, and we are going to read this. So basically, the central goal of engineering of artificial intelligence is the design and synthesis of useful intelligent artifacts. We actually want to build agents that act intelligently, such as agents are useful in many applications. So basically, the central goal of artificial intelligence, right, is to synthesize how we as humans, our brain work. So they try to synthesize this information into something useful, and then they try to design these technologies that we have seen so far, like ML, deep learning. We now have agentic AI, robotics, and so forth. That is called these artifacts that are called intelligent artifacts. But as this keynote I'm giving right here, it's about agents. At the end, they want to take this synthesization and designs, and they want to build these agents that will act intelligently, such as humans, that can create useful applications that are very specific domain. So just to close up this small talk, artificial intelligence has many domains of study. The one I will be creating some content on is on agents, specifically agentic AI. But before we get into that, we need to understand the fundamental concepts. And just remember that there is an environment all around us, and there are agents, and those agents can be humans, or those agents can be machines. Those agents can be dogs, cats. And these agents will take information from the environment. And based on this information, they will do some thinking process inside. And that's what artificial intelligence is very interested in the thinking process that will lead to thoughts. And then these thoughts will get back into thinking process. So that loop of thinking process and then thoughts is what artificial intelligence is very interested in. Remember also that agents have some limitations. It can be resources, informatic constraints that can affect the end results. And also, these agents are very specific domain. And at the end, that is what you want to build with these technologies on Crew AI, Autogen, and other frameworks to create multi-agent interactions. The fact that you can create specialized agents to solve specific problems based on the limitations they have and the information that they can get from the environment in order for them to learn, improve, and get better results at task at their own.